right, another common practice that we have in pre-calculus is we need to be able to rationalize the denominator. And I know you've done this in other classes, but to rationalize denominators, you have to use the conjugate of whatever your denominator is. So if we're looking at number 12, we want to rationalize the denominator. So in A, we have 5 over 3 root 2. We do not like to have irrational numbers in the denominator. So the way we get rid of this is we multiply by root 2. If you multiply the bottom by root 2, you have to multiply the top by root 2. So your numerator is just going to be 5 root 2. Remember, the 2's on the inside, the 5's on the outside. You can't multiply those. And then we have this 3. And then the square root of 2 times the square root of 2, well, that's going to be the square root of 4, which is just 2. So the square root of 2 and the square root of 2, that's always just going to be 2. So then we can finish this out, 5 root 2 over 6. Now, if both the numbers on the outside, the 5 and the 6, if they're both divisible by the same thing, you can go ahead and reduce that further. 5 and 6 are not, so you are just done there. All right, in part B, we have a cube root in the bottom, and this may be something that you haven't seen as often, so listen carefully on this one. But what I want to do is I want to factor the 25 as much as possible. It's going to make this a little easier to look at. So this is the same thing as the cube root of 5 squared. Okay, so anytime you can factor that, it's going to be a good thing. Now, remember when we were doing the simplifying with our radicals, if we were doing the cube root of 108 or something, we did a factor tree on it, and we were allowed to remove things that are in groups of 3. Okay, since it's a cube root, we need groups of 3. So going back to our original problem, we have 5 squared. If we have 3 5s, if we have 5 cubed, then the cube root and the cube are going to cancel each other out. So what I'm going to do is I'm still going to multiply it by the cube root of something, top and bottom. My goal is to have 5 cubed in the bottom, so that the cube root and the cube cancel each other out. I already have 5 squared, so that means I need to multiply by 5 to the first. So on the bottom, this gives me the cube root of 5 squared times 5 to the first. You add those exponents, so we have the cube root of 5 to the third. I'll deal with the numerator in a minute. Now, at this point, the cube root and the cube will cancel each other out. So we're just left with 5 in the denominator. And on top, we just have 1 times the cube root of 5. There's nothing you can do with that, so this is your answer. Okay. I'm going to give you one more example of this, just so that you can see it. So let's say the problem was instead 1 over the cube root of 2. Just leave it at that. Okay, now 2 is to the first power. I can't factor it any further. My goal is to have 2 to the third power, because I want the cube root and the third power to cancel out. So I'm going to multiply by 2 squared, top and bottom, the cube root of 2 squared. So that gives me in the denominator the cube root, 2 to the first and 2 squared. We add our exponents, that's 2 to the third. And on top we just have the cube root of 2 squared. So now in the denominator, the cube root and the cube cancel each other out, and we're just left with 2. And on the top, I can't cancel that because that's a cube root and a square root, so we're just going to leave that as the cube root, and 2 squared is 4. So that's your answer. Okay, so I know you saw those in Algebra 2, but maybe it has been a little while, so you might have forgotten. Okay, we can also rationalize the denominator if it's a binomial on the bottom, so that's 2 things. So if, for example, you have root 6 minus root 2, in this case, the conjugate is the same numbers, opposite sign. So we're going to multiply by root 6 plus root 2, top and bottom. Okay, the top, I'm just going to leave that alone just for a minute. You could distribute the 8, but I'm not going to. I'm just going to leave it be. On the bottom, we're going to FOIL this. Okay, here, 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 and here. Okay, so root 6 times root 6 is just 6. Root 6 times root 2 is root 12. Negative root 2 times root 6 is negative root 12. And negative root 2 times root 2 is negative. Root 2 times root 2 is just 2. Okay, so that's just from the FOIL. Notice my middle terms cancel out. That is always going to happen because you use the conjugate. Those middle ones are always going to cancel out of that. So we have 8 root 6 plus root 2 over, let's see, 6 minus 2 is 4. And since these numbers, the 8 and the 4, they're both divisible by 4, I can go ahead and reduce those. So my answer is 2 root 6 plus root 2. And you can leave your answer like this, or you could distribute the 2 through. It'd be 2 root 6 plus 2 root 2. Either one's fine. Now, sometimes in calculus, we have to rationalize the numerator. It's the same process, it's just you're doing it to the numerator. And this is a technique you would use in calculus. So if the directions say rationalize the numerator, just do it, you can do it. So we're going to multiply by the conjugate of this, which is 2 plus root 2. We're going to do that on the top and bottom. Now, the denominator, that's the one I'm just going to leave. I could distribute that 3, I'm not going to right now. And then the top, we're just going to FOIL. Here, 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 and here. So 2 times 2 is 4. 2 times root 2 is 2 root 2. Negative root 2 times 2 is negative 2 root 2. And negative root 2 times root 2 is negative 2. Now, if you get to a point when you're doing your you're doing these in your homework problems or whatever, and you're like, well, I know that those middle terms are going to cancel, yeah, go ahead, skip that. Don't write that out. But just so you know, it is a FOIL. Those will cancel out. So in the numerator, we have 4 minus 2, so 2 over 3, 2 plus root 2. You can leave your answer like this, or you could distribute the 3 in the denominator and make the denominator 6 plus 3 root 2.